Hello, everyone. Good evening to all of you, and a very hearty welcome to the webinar series organized by Asim Premji University. Today, to the webinar, we have the topic Helping Children Learn Mathematics. We are here. My colleague Raki from School of Education at the Asim Premji University would be, we will be having a discussion on issues around teaching and learning mathematics. Uh, we would spend about 30-40 minutes talking about this theme and then keep 15-20 minutes for question and answer at the end of the session. To kick start this discussion, let me give a very brief context. For all of us, from our own experience of schooling, mathematics has been a very unique subject. Finds a special place in our curriculum. Probably that's one of the only subject which is taught throughout the schooling stage, and that also finds a place in across the curriculum, not only in our state curriculum but also across the board. The other special aspect of mathematics is that for some reason, children always find learning mathematics difficult. And same is true with coming when it comes to teaching of mathematics. Teacher find it a little hard to engage with that. Today, we will be taking some questions on understanding this issue of teaching and learning mathematics. To start with, I invite Raki to let us know how true it is to say that students struggle to learn mathematics in school.
Hi, Sharad, and thank you for setting the context and thank you for anchoring this session. Um, uh, yes, there is some issue with teaching and learning of mathematics that we all acknowledge. And I think acknowledgement is the first step to trying to get it right, at least to the extent we can. So, to start with, let me just show you some large-scale data that NCERT collects every 2 years and presents. And this is widely circulated and available through newspapers, through websites, and so on. So, NCERT asks some very simple questions, recognizing numbers 1 to 9, recognizing numbers 11 to 99, which is basically a 2-digit number, doing a subtraction, which requires some regrouping, and doing division. These are the typical kinds of problems that they ask.
Now, so this is the question from the national level survey that is conducted.
Yes. The annual survey that Pratham sort of conducts every year. And we see that there is some learning crisis. So in 2025, the ASER data shows us this kind of pattern. You see that from 2014 to 2024, the government and private schools all put together has made marginal improvement in learning or in grade 3 children who can do subtraction. So they have gone from 25% to 33.7%. Similarly, in grade 5, students who can do division has also marginally increased from 26% to 30%. One does see that there is some variation between the government and private schools, but let's not, for the time being, not worry about it. So roughly 1/3 of the students are learning to do grade appropriate mathematics, and the ability of students to learn grade appropriate mathematics as we grow up the grades reduces. So that's also alarming. So from grade 3 to grade 5, there is a slight dip.
So you seem to suggest that this is true across grades and everywhere in the country.
Yes. it seems it's a large scale data, and there is other data which is generated by NCERT through a national achievement survey. It also shows something very similar. What we also see is that from grades 1 to 8, now this table is not an easy table to read, but how you read this table is to see. So yeah, I have highlighted grade 5. So children who cannot read even 1 to 9 in grade 5 is 2.3%. Children who can recognize numbers, say till 11 to 99, rises up to 30%. I mean, they can at least do this. This is only at least and not at most. Then children who can subtract, at least 25% children can do subtraction. And similarly for division, at most the children, so children reach the level of division, they are 30.7%. And cumulatively, it adds up to 100%. Okay?
So these are the competencies that fifth graders are supposed to be having, and about less than one third of the students are able to do
Yes. To
some of
reach
these.
division. Correct.
Yeah.
Yeah. Yeah. Um,
And
so
and
children seem to be moving from recognizing numbers in grades 1 and 2 to be able to do some subtraction in 3 and 4, but roughly one third. Say 5 and 6, roughly again one third of the children end up, that's the maximum level, they end up dividing, and it improves some bit more by getting to almost half the children in grade 7 and 8 can do division, but which also means maybe half the children are not still able to do division, which is the alarming thing. And that's what I was sort of, and you were hinting at a learning crisis. This seems like a little off the mark.
and is it a new phenomenon, or is it has it been like this for some time?
I mean, it seems it's been, because this data is from 2014 to 2024 of a very similar kind of test. The test does not change, has not changed radically in these years. So it seems at least it has been there for these many years and might have been there earlier too.
So, what you're saying is that the status of student learning, particularly when it comes to mathematics in school level, is not very encouraging,
Yeah.
to say the least. And it is less than half of our students are not able to learn what they are expected to learn. So let's try to understand this. I mean, I get to read a lot saying that learning is a function of many factors that operate in the school and outside the school. Some of them are student related, some of them are teacher related. Could you throw some light on what operates
Yeah.
on the classroom level? Yeah.
So while, as you're rightly saying, Sharat, that there are several things which we can't control, and those, so hunger, poverty, socioeconomic status, functionality of schools, all these may be responsible. I'm going to give you a couple of small snippets from reasonably well functioning schools to probably understand what might be uh, bothering the teaching and learning of mathematics. So let's look at this grade 2 class, and the teacher is teaching comparing numbers, which is something all of us learn. The teacher uses a metaphor of hungry dinosaur and says it has big mouth, and therefore he will always eat big numbers. So this is to sort of say what the symbol looks like. So there is a metaphor now which children are likely to use to put the symbol. That the bigger the mouth, the bigger the number. But then she gives these 4 rules. At first, count the number of digits. If it is same, check the hundreds place. If it is same, check the tens place. If it is same, check the ones place. And through this process, she is demonstrating to children how to compare 549 with 502. And she on the blackboard writes these two numbers, underlines 4 and 0, and see, by the rule, I checked the hundreds place, it was same. I checked the tens place, there's a difference, and then I can quickly say that. And then the teacher says, if you do more practice, you will be clearer. And then
Yeah,
the
from
teacher,
our own.
sorry?
Yeah, good, good,
Yeah.
good, good, good.
No. So the teacher asks the student, one picks up one student and asks, compare now 176 and 167. And the child says 167. And as a reason for his response, the child says, I compared the last number. Now, after a brief interruption, the teacher says, when we add, we start from the units place. When we compare, we start from the hundreds place. As if this is very obvious to everybody where one should start when one does one thing versus another thing. Yeah, please go ahead. Yeah, your question.
Yeah. So from our own memories of school,
Yeah.
our teachers have given us rules of operation
Yeah.
in learning mathematics. We grew up learning a lot of rules and writing them up in the tests. So
Yeah.
what is this? What is the problem in this kind of an approach?
I mean, the problem is hidden in the small example itself, that the rule is given and the child still says the wrong thing and uses a rule that he or she thinks is better. And then the teacher gives this final rule that if you practice, you will get it right. And second, if you have to remember in which kind of question what you should follow. But for the child, how does the child remember? A 6-year-old, 7-year-old, how does a child remember all of this now? Yeah. So
So you're
let's look at,
saying
yeah, sorry, please.
you're saying there are large set of rules that we keep communicating to children without making distinctions, and
Yeah.
we only expect them to use their
Yeah.
okay.
Yeah. So in this small episode, we have given them 4 rules for comparison and a 5th rule to say when you should start where.
Yeah.
Yeah.
And at a single glance, at one glance, it looks that the two rules are quite contradictory to each other, and child has to make a distinction on
Yeah.
which rule to be used in what circumstances.
Yeah. Yeah. It's too much of an expectation from a child who is just learning these rules of the game, as we call it, of mathematics. Yeah. So I'll show you another contrast to this. And this contrast has some activities which also we are very fond of. And this is a grade 4 class. And the teacher engages the children in measuring various objects using a ruler or a scale. Now, what happens in the class is the entire 40-minute period, children spend in measuring objects in the class. The desk, the window, the door, several kinds of things. Now, in the measurement, students do indicate that they know some basic principles of measurement. They know they have to start at the corner of the desk, align the starting point of the scale with the end point, with the starting point of the table, and repeat the scale many times to measure it. But what we also saw was they were not very conscious about putting the scale straight. So which means they were not measuring the edge of the table anymore. They were measuring something else, or even aligning with the 0 mark rather than the starting point of the scale. You can distinguish that, right? You have a scale and the 0 is often not the corner of the scale. So children don't seem to distinguish between these things. Some children simply round off multiples of 15 or 30 as their scale was. Some measure more accurately, but measure only in whole numbers and not worry about the millimeters. Some children actually find out that every time they're measuring, they're getting a different measure. but they are not necessary. They repeat it, but they're not careful about how they're measuring. And the class does not discuss this, does not use these as opportunities to discuss. And the next class, they go back to an algorithm of adding and subtracting um, measurements like length.
Yeah, but our educational practices seem to suggest that an activity-based, context-driven engagement provides meaningful learning opportunity to the learner.
Yeah.
What is happening here?
I think what is happening here is the math gets sidelined and the activity dominates. So everybody is very active in the classroom, but they are not worrying about the mathematical principles that should have come out. It was an excellent opportunity actually to discuss several measurement principles, including why a zero is required on a scale, while when we count numbers, we don't require any such thing.
Yeah,
But
we
these
start
are
with
not
one.
things that we are asking. Yeah. Why don't we start with one? Why do we start with zero? And if we open the class, maybe children will ask this question. And that will give the class a very enriching moment to understand the difference between counting numbers and measurement.
Yeah, as such, the activity itself is not a problem, but how we have been using
Yeah.
these activities to
Yes. Yeah.
achieve what is intended to be achieved is somewhere we are
Yeah.
missing the target.
Yes. Yeah. I mean, it's a very good activity to get children to measure. It's a very good thing that children got different answers to the same desk measurement,
Right.
but it was not problematized why we got the different answers.
So we are also saying that it is all right for children to make mistakes in doing
Absolutely.
measurements,
Yeah.
but they will have to be explicitly discussed in the
Yes. Yes. Yeah.
classes.
Yeah. Yeah. It's perfectly
So
fine for
you
children.
also said in the next class teacher went back to conventional rule of making measurement related problem solving.
Yeah. Yeah.
So, I mean, is how is the general transition of this kind problematic in your understanding?
So there were so which means in children's mind they might be actually thinking that there is no closure to this. This was only entertainment and not mathematics. While the real mathematics lies in solving problems on the board and in the notebook and in the book. This is just something, some entertainment for one day. Because we will not even assess something like this.
Right. So relating everyday experiences to the mathematical content is useful, but engaging with that experience consistently is equally important, is what you're trying to say.
Yes, 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 yes. Yeah,
Okay. So this is with teachers, how teachers engage
yeah,
with
yeah,
mathematics and how do they present content to the children. Are there other factors that we generally see that might be
yeah.
leading to kind of status that we are currently in?
Right. So let's look at this. There are these two statements, one from a grade 2 class and one from a grade 8 teacher. And both are very similar. So grade 8 teacher says that's a rule. So we were speaking to the teacher about why decimal points are placed the way they are. And the teacher says that's a rule, that's a basic rule which they introduced. That's a basic rule they invented. We are following from olden age. So then it's a rule. So maths is completely about rule. And since these rules have worked all through the ages, therefore there is no reason to question them. Similarly, a grade 2 teacher says, tell me the rule, give me the reasons. Maths has to follow rules. That's why we always ask you to follow rules. Do this, don't do that. So from grade 2 to grade 8, there is just no difference in the ways we make children. Um, we introduce children to mathematics or make mathematics accessible to children. We are just repeatedly telling children that mathematics is about rules and there
And a
is
list
nothing
of
else.
rules.
And a
And a
list
list
of
of
rules.
rules.
Yes.
And when a contextual problem appears, that sits separately without getting
Yes.
connected to.
Yes. So that's what
Yeah.
all children and all teachers also claim. Children find problem solving very difficult. Word problems, as we call them, are very difficult for children because they are not amenable to rules in the same way as an arithmetic problem is. Yeah.
And it is also used up as a way to say you learn the content and then
Yeah.
apply that content
Apply
later
it.
on.
Yeah. Yeah.
Is that a problematic way of presenting?
Uh, yeah, learning anything without embedding in one's surroundings or one's experiences, larger field of experiences, which could be make believe experiences as well as real experiences, I think is disconnecting for the child. So the child does not learn language in the same way, isn't it? Child learns language by speaking, by talking, by making errors, by being corrected. But mathematics as a language also has to be perhaps learned in the same way. By talking, by making errors, by making some conjectures and some hypothesis about how does it work. They are trying to test, right, how things work in this world. And if we don't give them this opportunity, and this opportunity seems to emerge nicely through problems and not discrete arithmetic, addition, subtraction, column algorithms only. It allows them to think, reason, connect to other ideas, and that's when learning happens.
So the other thing that constantly seeming to be happening in maths class is bringing a lot of materials and
Yeah,
the belief that materials will help transform our classrooms.
yeah.
What is your take on that?
So it's the same as activities, right? Materials we do activities with, and therefore, in the same way, if we can't assume that the material will tell children what to do with it. It's not like a flower where we can look at the color, remove its petals, or count the number of petals in it, and so on. Mathematics is not like that. So, therefore, there is nothing in the material which tells what to do. We have to somehow encourage children to use the material in a particular way. And when they learn to use it in that way, then they also start examining mathematical ideas. So, materials are useful. They are useful in different ways in different grades, but they have to be introduced very carefully to children.
So, like what you referred to, contexts and
Yeah,
situations which are
yeah,
not integrated meaningfully into consistent teaching practice. Materials are also coming as one of
yes,
ideas
yeah,
which are
yeah,
used for a while and then left and then
yeah,
used again. So,
yeah.
so as a whole, all these pieces are not coming together
Coming. It's a
in
jigsaw puzzle of which there are several parts. They have to come together to make mathematics alive in classrooms.
yeah, yeah. Right, right. So I would like to let the audience know that Raki has been leading the exercise of writing textbook for NCERT. She is the lead for all the primary grades up to grade 8, and we want to know from her. Um, Experience of drafting textbooks and engaging with textbook authors, uh, what approach they actually follow while drafting the textbook, and how that is consistent with what we have been talking, making meaningful connections and bringing all together in a holistic manner.
Yeah.
Raki, can you tell us a little about the generic approach that you people have adopted while drafting the new textbook series of the NCRT in the
So,
last?
just a small correction. I was the lead for grades 3 to 5 only. Somebody else's, but I have contributed till grade 8. So, before we get into that, I want to show you something and to which we were responding in the textbooks. If you can see this. So, this is a ex-student of our own university, and she worked with grade 6 children in some part of India, and she asked children to draw an image of what they think mathematics is. So, what is the animal they can closely relate to when they hear mathematics? It's a very, very strange exercise, but it has been extremely revealing. So, this child says it's a memory power. There were several responses. I just picked up one. It's a memory power, it's the biggest animal. Yeah. So it gives us some sense of what the child is thinking about mathematics. It's an animal and it's all about memory, which we just spoke about. Yeah. It's because teachers give you rules, you have to memorize them. And here is another thing. Sometimes I'll get fear that my answers are wrong and I shy to ask the sums or understand it by our teacher. There are many big definitions which I can't remember, but I try it, and many hours later, I understand what the teacher have taught in our classes. There are so long formulas and divisibility tests are so much. You see the frustration that children are
Yeah.
exhibiting? We were in the textbook, one of our things is that we will not give them rules to begin with, at least. We will try and arrive at them in the smoothest possible way. However, every time you do introduce a particular procedure, algorithm, rule, it does come from somewhere which is not the children's own voice. We did try quite a bit to use loads of illustrations and materials to help children make some basic sense. Even if they don't understand the procedure fully, is there a step before that which the child can rely to get a good sense of whether he or she is in the right direction?
So,
Yeah.
in that sense, rules are not completely out, but the
Yeah.
process to reach the rules has been given significant emphasis.
Yes.
Yeah.
Yeah. So what we see is, I'll show you by an example of a trajectory of multiplication in NCERT. This on the left hand corner, you can see this column arrangement, and children have done something. The question is it correct or is it incorrect? It seems correct by the look of it. But if you were to punch it on a calculator or anything, you will see that this is not correct. This can't be the answer, because 50 times 25 is going to be only 1250. So if I am multiplying by 49, then this can't be the answer at all. But children have made the best of what they understood in the classroom. So, in contrast to that, what we have done is, from grade 3 onwards, we have started telling children what it means to multiply. Multiplication has several meanings and several different representations. We start with something as simple as this. If each Rakhi requires 4 beads, then how many beads in 5 Rakhis? So you can just see that every Rakhi has 4 beads, and you can just add them up and you will get a multiplication. Similarly, we can tell that a kangaroo jumps 8 steps at a time. Which numbers is it? So skip counting. Children are very, very happy and fond of doing skip counting. So very gently we introduce them to these ideas. It does become more and more complex. By grade 4, we introduce them only to these kinds of images to help them calculate what the product will be easily. And these images are repeatedly used. All the textbook is filled with these images. So it's a bulky textbook because these are lots and loads of images. However, We help children see why this particular arrangement, which is called the box method, actually works. And we explain through many small, and every problem is broken into smaller steps to guide the children to think in what particular ways. And these images support this. Only by grade 5 do we try to explain to them how the method works.
So
So
it is
3
important
years.
to see how one idea has evolved over
Yeah.
3 years of
3 years.
study.
Yeah,
Yeah.
it's 3 years when children learn that. And we have tried to do this with almost all content. We start with only these very basic preliminary images, and we become more and more complex every year, hoping that the previous year's knowledge will feed into this year's understanding.
Has this been approach consistently used across the textbook?
Yes,
Any other?
even in grade 6, we have done some bit of that. We see again very basic images of a chikki being divided to making it roti being divided to coming to number lines. So we have done that quite a few times. I mean, across actually. And therefore, the textbooks have also become very bulky because our primary concern was that the student should be able to relate to the textbook, should be able to read pictures, interpret from pictures. So even if assume some child is not able to write so much in the formal mathematical way, then maybe pictorially the child will be able to argue his or her understanding. So that's what we have primarily done.
So, as a teacher, someone who is going to use this textbook, how does this all come together to make a classroom meaningful and connected?
Yeah. So I don't think the textbook in itself will be able to do that. So we are in the process of writing teachers' handbooks, trying to explain our approach in each grade, why and how we have elaborated the content. Loads of teacher education, teacher training, which also means loads of teacher educators to help them understand and unpack the textbook. Because this is not very conventional, at least in India, to have pictures, picture book kind of maths book, no? In grade 6, 7, 8, every grade is like that. Loads and loads of pictures. However, the pictures also differ. I mean, there are loads of people in the primary grades, while there are loads of mathematical illustrations in the secondary, in the middle school. Uh, so I think it requires loads of loads of people on the ground who understand how mathematics can be made meaningful for children. I'm not saying necessarily this is the only way to make meaning.
Yeah.
And I'm also not claiming that we have solved all the problem of meaning making and all the problem of disconnected rules. We might have missed several things. Given the pressure on the teachers every academic year, these books may also be very demanding on their time. So we are not very sure how much of this can be done in classroom. But it is only in the next couple of years that we might get some valuable feedback from teachers and from NGOs and people who work with teachers to improve these books. This is just a beginning, I would say.
Well,
Yeah.
yeah, well, I see that this textbook brings together many understanding of how children learn, how learning can be facilitated, what kind of supports are required, and how learning goes on a continuous progression from one model to the other. I see it requires a wider understanding of the
Yeah.
domain as well as a pedagogical understanding of how to deal with it. I'm very it was very insightful, your discussion. So coming to the other part of it now, for a teacher or for an educator who makes use of this textbook or engages with teacher, there are many things that need to be understood. There are
Yeah,
it's a systemic effort that
yeah,
in a way that is required to make changes to the situation that you referred to in the beginning, the learning crisis that you referred to. Can we talk a little bit about how a master's in education program
yeah,
uh, uh, tries to bring this together? Could you elaborate on
yeah,
a bit on the nature of the program that is
yeah.
offered at Azimprem University, and then connection to what you have referred to before?
Yeah, so the MA education program at the Azim Premji University is a pretty holistic program. It's as you said, it's geared towards the system. So, the program itself helps students understand the fundamentals of education, because any of these subjects do not exist and cannot exist in void. It exists within the education system. So, understanding the system, possibilities that the system leaves us with, the constraints of the system is terribly important. Also, a broader philosophy and understanding of the society within which schools are situated. I think so. Our master's program actually helps develop some of these basic fundamentals of education through core courses, which are nine. And but it also allows students to do an almost similar amount of elective courses, which is eight, of which four of these are in a subject area, and they're just basically supposed to choose math, science, language, social studies. Each of these
One one
subject
of
areas,
one of these
one of
math
them, one
science.
of this, yeah, one of this. Each of the subject areas then deal with what is the nature of that subject, how is the school curriculum and syllabus thought about, and how can, so in the case of mathematics, we actually talk about how do you reimagine teaching of mathematics and the school content. So we spend quite a bit of time doing that. Now, it is not just this. The program actually allows students to engage with a lot of field practice. So, where they can have some opportunity to try out some things that they have learned, and develop newer insights. They come back and feed us. So much of our understanding of how the society has been working, or how the education system and maths classrooms have been working, we have gained these insights from our own students. In fact, the textbook is also, let's say, a accumulation of several efforts that many people have made. It's not a single person's effort at all. It is multiple ideas that have fed into something like this. Um, so the MA education program, in that sense, balances basic foundations of education and foundations of the subject areas that are taught in school. And every student gets an opportunity to study one such subject area. So,
And during the program, you refer to three important field
yeah,
opportunities,
yeah,
and also during the semester there are opportunity for the students to
yes,
engage in the
yes,
school
yeah,
context.
yeah.
Can you elaborate a little on that?
Okay. So during the semester, students actually go to schools and in the neighborhood of the university, and engage with children, teachers, schools holistically. However, these are one off, sort of every week, and a few times in a semester they can do this. But the three longer duration field practice in semester one, between semesters one and two, and at the in semester 3 they engage with successively longer durations in the field, and they go to fairly far flung remote areas of the country to experience how this education system work, how do schools function, how teaching learning happens, and within that complexity of the system, how can I make a small difference to my children. And we generally get very, very positive feedback from the students about their experiences and what they have learned. They really transform themselves through this process.
So there is a bulk of courses that they engage, and there is equal amount of engagement in the hands-on
Yeah,
mode,
yeah,
field experience, and they talk to each other to make a lot more sense to understand the education
yeah.
as a domain of practice, right? So as an applicant, so I mean, anyone with any graduation can apply and get started into engage with these courses, the core courses that you referred to.
Yes, see, you do have to apply and appear for an entrance examination. On the website, the dates and everything will be available, and they will be also available through social media channels. So you do have to appear for an entrance, and during the entrance, you have to also commit to a subject area. Your interview will happen after you clear your entrance written examination. And in the interview, you will be explored further about your interest in the subject area you had chosen. And many other, your general interest in education is also significant. I mean, you should have some basic sense of what you want to do in the field of education. I think that we really, really require from our students. Some
Right.
basic motivation and temperament to engage with this very complex education system of our country.
Right. And during the semester, what is the mode of engagement? Are the students expected to read, write,
Yeah.
reflect?
Okay. Yeah. So we do expect a fair amount of rigor. We in all the courses, whether they are core courses or electives, we often read original pieces by authors. We also watch loads of videos, and we look at diaries of individuals who have published them. We look at several kinds of things. We look at images like the one I showed you, and try and understand what is the child trying to say by drawing an elephant. Does it relate to us? And things like that. So we do try to engage the students in reading as well as in watching videos, watching movies, reading, looking at documentaries, looking at diaries, teachers' classrooms, interviewing children. They just engage in a whole lot of things. They can engage with all of this when they are committed to making the change themselves. Yeah.
How do they connect the dots to respond to the learning crisis that you referred in the beginning of your conversation?
So, I mean, the field opportunities are one such where they will bring together. Sometimes the crisis in school could be very much about children not being able to sit together and work on something. And that's not just a mathematical problem, no, that's an
Right.
educational problem that could be because of discrimination, because of certain kinds of ideas that a society may have, a community may have. And getting the children together and breaking those boundaries, girls and boys won't sit together and talk to each other, breaking these are all sociological and philosophical ideas. Do I really believe that all children can learn? Yes, if I do believe in so, then I will do something to help pull children together and not push them apart. So you have to bring in judgments um, from everywhere, and from all disciplines, all courses you have done, to be able to work in classrooms.
Yeah. So as a program, how does it support students to engage in the reading, writing, lectures, and all? What kind of support system exists within the
Um,
program?
so our faculty is very, very gentle and nice. We are very welcoming of our students to come and meet us in specified hours that we each of us provide. That's one level of support that we provide. They can meet us if they don't understand something, and we can sit with them and read. We have something called the Academic Resource Center, where also they can go and get help with reading, writing, developing comprehension skills, and so on. What else? Um we do have some peer mentoring systems also. Peers help each other. We do loads of group work and pair them in such a way that they will all support each other and develop. Our classrooms are very, very discussion oriented. Everybody has to participate to gain the best out of the classrooms. So it is in several ways that we will support. English language also we will support to some extent, and then we leave it to the student to pick up and develop more.
Yeah. How about people who have been working and joining the program? How program attends to their experience and their needs? Have such people found this program engaging and insightful?
I would think so. In the experience that we have had with the math students, where they come with experience, they have generally found loads of merit in doing this and going and growing with it. So the discussions in the classroom actually allow people from different backgrounds to share their prior experiences, whether it's a lived experience or in an organization experience, but it allows them to share those experiences and enrich each other. And that's how they get assimilated. They also learn some things that they might have missed in their own practice.
Right.
That's, of course, yeah.
Right. I think we have had a very fruitful conversation around
Thanks,
helping
Sharad.
children learn mathematics and how this is addressed within MA education program. It is time for now to take up a few questions. There have been many questions in the comments box. One question from Ashutosh Singh: how can we make maths and science accessible and attractive for persons with visual impairment?
Yeah, it's a good question, a tough one. Uh, See what has happened. I mean, many times we don't often offer maths and science courses at higher grades for children with some disabilities, no, especially visual, because there are several visual elements in these. Uh, then uh, the the thing is that with advent of technology and better technology to support them, I think there are ways. I am not the best one in this. I'm not an expert in this, but I know that there are people who have been working quite hard to make advanced ideas of maths and science available to children without vision. And it's not that they can't. They're pretty good. To my limited knowledge, they are pretty good in making sense of it.
So there is another question. No one cannot change the rule to simplify numerical problem with mathematical operations like addition, subtraction, square root. Is that activities will help or practice?
I'm not very sure what it means, but I am imagining that she's asking whether if rules are not given, then will activities help, um,
Or practice.
or practice.
Yeah.
So practice we have been doing, but practice has not necessarily led us to achieve everything. I'm not saying practice is not important, but meaningful practice, which means giving different kinds of problems, different contexts within which the same problem might emerge, similar ideas might emerge, might help. Now, the other thing that I might want to say is that anything that we see or we think cannot be reasoned with. need not be taught. It's a very hard stance, but I would feel if we think that something cannot be explained to children at that time but will be explained later, then we might as well teach it later. So only doing activity in place of the practice will not help, as we discussed earlier also.
Right. There are no other questions. There are more of comments on what you have been saying, and most of these
Okay.
comments are in confirming
Okay.
or in
Okay.
agreement of what you have said. Uh, one comment is on preparing a teacher's handbook to support
Yeah.
what has been done in the textbook. If you were to be developing um, handbooks to support teacher, what would be needed in such a resource book?
Uh, I think somehow we have to communicate to teachers the motivation behind the change. Why
Right,
are we doing it like this?
right,
And include them in this conversation of the change. And slowly and steadily, teachers will pick up. It's just
right.
that they are also very overwhelmed and stressed out. They have too much work. So we have to be patient and we have to support. We need loads of people.
Right.
Uh, and maybe programs like ours will also help feed in people who might be able to support teachers going forward. Yeah.
And it is not a one-time effort. I mean, it
It's
will
not a
have to
one
be
time effort.
long-term,
It has to be
long-term work.
sustained. Yeah.
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 So there's one more question. How about giving bridge course practices for primary levels?
I don't know, but maybe doing these many of these courses, children are already overwhelmed with the amount of practice and rules that we give. If we do another bridge course, then we will give even more of that. More of the same is not very useful. Little of the different may be more useful and more effective in getting children to learn and appreciate the subject itself.
Yeah, spending more time with each of the concepts
Yeah,
and letting that settle
yeah,
in into students is what is
yeah,
highly important.
yeah.
Right. I don't see any other questions. So if you have anything else to say as a concluding remark, we can have that, and with that we can close.
I think many people should get interested in doing mathematics for the school level. I know there are many mathematicians who are very, very fond of mathematics. We also need loads of people who are interested in school mathematics and want to make it better and improve the scene and improve this learning crisis, reduce the fear that children have. Yeah, I think that will be great if we have, whether part of the program or without the program, but we just want more people, more hands to contribute to this.
As you speak, there is one more question. How can we support a student when he knows the concept but struggles in understanding the question?
Yeah. Uh, Understand the concept, struggles with the question is a very typical phenomena that Sharad you were hinting at earlier. When we do teach them rules and procedures first, and then we ask them word problems to apply it. Uh, so that is one. So application should be the ground in which we learn rules and procedures whenever over a period of time. The second is I don't think we ask questions in ways by in which children understand the language. Our everyday language, whichever whether it be the mother tongue or English, whichever be the language, the spoken language that we often use is different from what we write in the textbook.
Right.
That contributes to a lot of confusion, lot of difficulty. If we avoid such questions, such language, Make it simple, conversational language. I think children will develop a lot.
But even while solving a word problem, we tend to suggest what is the key word and identify an appropriate strategy to answer the question based on keywords.
Yeah.
What do you think about that?
So that's the same problem, no? Because children can't comprehend the language, we tell them how to comprehend by underlying the keywords. But the problem is with the same keywords, I can create a problem which is not does not use the same operation. So more means addition, but I can create a problem where more means subtraction. So instead of trying to help children in these instrumental small ways, we should help one, we should reduce the difficulty of the language. Second, let's ask children to draw pictorially what they understand of the problem. That is actually very, very useful for children. When they start comprehending, they can solve it. The problem is one of comprehension. Yeah.
Right. Right. So, a a learning which is based on comprehension, not on rules,
Yeah.
is a approach that probably is what we are hinting. And with that words, we would like to close today's session. Thank you so much for this conversation, Raki. It has been highly insightful, and we will have more opportunity to talk in this webinar series. Thanks to all the participants who have been part of this webinar. Thank you. Thank you very much.
Thanks, Sharad. Thanks, Sharad, for doing and hosting, anchoring, and steering this conversation.
Thank you.
Yeah. Thank you so much.